A sea star the size of a bicycle wheel, 24 arms, faster than almost anything else of its kind. And yet, within a few years, it nearly vanished completely. No witnesses, no obvious cause. It would take scientists a decade to understand what had happened. 2013, the Pacific coast. The sunflower star, Pycnopodia helianthoides, begins to disappear. Not gradually, but almost simultaneously, all along the coastline. The sunflower star is the main predator of sea urchins. It keeps their numbers in check. Urchins, in turn, feed on kelp, vast underwater forests sheltering hundreds of species of fish and marine mammals. Remove the star, and the whole chain fails. When sunflower stars began dying en masse, the global population fell by roughly 90%. In California, the species was nearly wiped out. Freed from their predator, urchins stripped the kelp bare, turning thriving forests into barren rock. The question, what was killing the stars, and could it be stopped? For years, the investigation stalled. There was no cell culture in which to study a possible pathogen, nowhere to even grow a suspect. Days before death, a healthy star's arms would curl, then drop away as its body dissolved. Too fast for stress, too consistent not to be an infection. But which one? Warming waters were considered. A virus was considered. Neither gave a definitive answer. Between 2021 and 2024, researchers ran more than 20 separate experiments, a slow process of elimination with no shortcuts. The answer came from a routine comparison of data. Hakai Institute researcher Melanie Prentice was comparing the genetic material of healthy and dying stars and noticed something striking. Infected stars were dominated by a bacterium of the genus Vibrio. Healthy ones barely had any. As senior author Alyssa Gaiman put it, when we compared the fluid from exposed and healthy sea stars, there was really only one difference. Vibrio. We all got chills. We thought, that's it, we found it. A correlation alone proves nothing, though. Researchers cultured a pure strain of the bacterium and exposed healthy stars to it. Of 20 stars exposed to varying doses, only one survived. The one given the lowest dose. Summer 2025. A 10-year mystery solved. The culprit, a new strain of Vibrio pectinicida, designated FHC-F3. Identifying the cause wasn't an ending, it was the start of a new chapter. In 2024, Birch Aquarium in San Diego produced fertilized sunflower star eggs for the first time. By 2025, a coalition of aquariums, research institutions, and indigenous groups had bred sunflower stars in captivity for the first time, raising 72 juveniles in Monterey. Across 6 partner institutions, the number of young stars passed 300. Then came an unexpected threat. In 2024, a diver working on a kelp restoration project in the Greater Farallones found a single wild sunflower star, in waters where none had been seen in years. A year later, researchers found a small surviving population at the same site. Similar sightings followed in Sonoma and Mendocino counties, the first confirmed wild sightings in years. It suggests something remarkable. Somewhere out there, stars with natural resistance to the disease may already exist, and they may hold the key to saving the species. In autumn 2025, the California Ocean Protection Council approved over $600,000 for the next phase, experimental releases and an expanded search for survivors. In 2026, the California Academy of Sciences plans its own spawning event, distributing larvae to aquariums nationwide. But the stars have not yet truly returned to California's kelp forests. Scientists still don't know whether resistance can be passed on to offspring. They've only just begun testing the first cages of captive-raised stars in Monterey Bay, watching to see if they survive where billions once did not. The cause of death has been found. But the next chapter, the return of the star to the place it vanished from, has not yet been written.